We're going to talk about standard position and reference angle. When we are looking at the unit circle, the special triangles become even more useful when we are using them in order to simplify questions with angles that we don't recognize or that aren't part of the special triangles. So we can kind of fit them into our picture. So before we get started on that, let's talk about standard position. Okay, we say that the angle theta is in standard position in the coordinate plane if it satisfies the following two requirements. We measure by starting at the positive x-axis, meaning we are starting at the coordinate 1, 0 on the graph, and we are moving counterclockwise. So I already mentioned that earlier, counterclockwise, and I'm never going to write this word again, CCW. So we're going from the first quadrant to the second quadrant, to the third quadrant, to the fourth quadrant, and this is what we identify as the positive direction. If we go clockwise, then we are moving in the negative direction. Okay, but we're always starting at this point 1, 0. So if I'm drawing the graph here, we begin at this point, and if I'm trying to reach some angle here, I start here and move counterclockwise, or if this angle is somewhere down here, I'm moving again from here all the way around to the third quadrant. So this is what we identify as a positive angle. And if I start here but move backwards in the clockwise direction, this would be a negative angle. Okay, so example 2 here, sketch an angle of 150 degrees and negative 120 degrees in standard position. Well, okay, where are the angles in the first place? If I'm staying here, this is 0 degrees. Up at the top is 90 degrees. Another 90 degrees gives me 180. The bottom will give me 270. And if I go all the way around, I'll get to 360 degrees. So if I stop where I started, it's 360. So 150 will be somewhere in the second quadrant, so somewhere here, right? So I'm going to measure from the positive x-axis over here. This is 150 degrees. Now in the 120 degrees, I see a negative, so I'm starting at a positive x-axis and moving backwards 120 degrees. Well, okay, this is negative 90 plus another 40. It's probably somewhere here. This would be negative 120 degrees. So always starting at the positive x-axis. Now, coterminal. Co means together, right? And terminal means a stopping point. So a coterminal angle are angles that share the same terminal arm. This refers to this thing here. Where is the stopping point? So that is what we call the terminal arm. So in standard position, we consider the angle in standard position, and a coterminal angle is any angle that has the theta that we originally measured plus or minus 360 degrees n, where n is any integer. Meaning, if I have an angle here, okay, let's call this degree theta, I can go around the circle and come back, and this would be a coterminal point. This would be theta plus 360, means I started at theta and I went 360, one whole circle around. That was 1. That's n is 1. Now if I go around the circle again, 360 degrees, whatever angle I end up with, is going to be theta plus 360 times 2, right? So coterminal means I've gone around the circle one whole time and ended up in the same spot. All right, let's talk about reference angle. Reference angle is an angle theta in standard position. So again, let's take a look at my example 2 here. Okay, whoops. Here we go. If I have 150 degrees right there, this is what we had from example 2. This is 150 degrees. This equals my theta, okay, in standard position. The reference angle is the degrees between the terminal angle and the closest x-axis. Okay, here's my terminal arm. And here is the closest x-axis. This is called the reference angle. And we use theta sub r as the reference angle. This is a really powerful angle because it will help us determine the ratios or the coordinates of the terminal arm, meaning we want to know what are the x and y coordinates of that point. The reference angle will actually help us figure that out because we don't have special triangles for all the different kinds of degrees theta could be. But we do have a reference angle for 4 key angles. We know 90 degrees, 30 degrees, 60 degrees, and 45 degrees. So the reference angle will help us determine what are the coordinates, and then we have to use some visual common sense to figure out what the whether the points we have are going to be positive or negative. Okay, so here's an example. Where is 120 degrees on the grid? Again, this is 90, this is 180, this is 270, this is 360/0, right? So 120 is somewhere over here. What are the coordinates for 120 degrees? Well, what's my reference angle? If this is 120, how many degrees do I need to get to 80, my closest x-axis? This is 60 degrees. Okay, well, I have a special triangle for 60 degrees, right? 60 and 30, 2, 1, root 3, and then I'm just going to draw my other special triangle as well. 1, 1, root 2, and this is 45 degrees, 45 degrees. Okay, 60 degrees. If I take the sine of 60, then I'm going to get root 3 over 2. Remember that sine of the angle represents the y coordinate and cosine of the angle represents the x coordinate. So the coordinates here are going to be the y value. The sine of 60 degrees is root 3 over 2. And what's the cosine of 60 degrees? The cosine of 60 degrees is 1 over 2. Now, the last thing I need to consider is where is it positive and negative? CAST. Sine is positive here, cosine is negative here. So sine is positive, so this is negative 1/2, the x coordinate. Positive root 3 over 2, that is the y coordinate of our point. So I don't actually have to work with the 120 degrees. I just have to figure out what is the reference angle. What's the special triangle that fits between the terminal arm and the closest x-axis? Let's try another example, 225 degrees. 225 degrees is going to be somewhere over here. This is 225 degrees. And the closest x-axis is going to be this one here. So if this is 180 degrees and this is 225 degrees, how much further back do I have to step in order to get to 180? this is 45. Okay, and the way that I did that is just take 225 minus 180. What's the extra bit? It's 45 degrees. Okay, if this is 45 degrees, then I know that the hypotenuse, the sine of my coordinates here we go. The sine of 45 degrees is 1 over root 2. And the cosine of 45 degrees is also 1 over root 2. And I need to rationalize it. And I need to figure out what's positive, what's negative. In my little coordinate chart up here, I know that tangent is the only thing that's positive. So that means sine and cosine are both going to be negative. So this is going to be negative. I'm going to rationalize it. Root 2 over 2, negative root 2 over 2. So again, when we rationalize, we are multiplying the denominator and the numerator by whatever's in the square root. So I'm multiplying by root 2, top and bottom. I'm in the third quadrant, so both my x's and y's are going to be negative. So the special triangle helps me figure out what the numbers are. And then this helps me figure out which one's positive, which one's negative. And again, we use a bit of observation as well. Okay, 330. That is almost a full circle, right? A full circle is 360 degrees. So here is my angle, 330 degrees. How much more do I need in order to get to the closest x-axis? I need 30 degrees extra. So I'm going to be using this triangle to help me figure out what are the coordinates. Okay, the cosine of 30 degrees is root 3 over 2. The sine of 30 degrees is 1 over 2. What is positive in this quadrant? Only cosine is positive. So my x-coordinate is positive, my y-coordinate is negative. And again, does that make sense? This is the fourth quadrant, right? Positive x, negative y. So we use our special triangles to figure out the coordinates along the unit circle. In A, we ended up in quadrant 2. In B, we were in quadrant 3. Whoops, that's not how we write a 3. 3. And C, we are in quadrant 4. So for each angle, we want to find two coterminal angles. All right, well, let's take a look. We started with 120 degrees. We started with 225 degrees. And we started with 330 degrees. So two coterminal angles means I'm either plussing or minusing 360 degrees times n for all of them. So if I add 360 degrees to 120, I'm going to get 480 would be a coterminal angle. Or I could even minus 360, and this will give me 240 degrees negative, right? Negative 240 degrees. These are all coterminal. If I add 360 to 225, some mental math here, 585 degrees would be coterminal. If I minus 360, I don't know if I can do that one in my head, negative 135. Let me just double check on my calculator here. 225 minus 360, 135. Perfect. Negative 135 would be coterminal. Here, if I added 360, I would get 690 as my coterminal degrees, or I could go backwards. I would get negative 30. I could also add 720, right? Oops. 720 is the same as 2 times 360. As long as it's multiples of 360, n can be any integer. and you will find coterminal angles. All right, find the reference angle for each of the angles below. Looking at A, we have sine of 120, cosine of 120, and tangent of 120. So what are the coterminal angles that would work? Where is 120? 120 degrees is going to be somewhere here, which means my reference angle is 60. So the reference angle is 60 degrees here. 225, oh, I believe this is just copying this one down here. So this is going to be 45 degrees. And for 330, our reference angle is 30 degrees. And again, using our special triangles, what are the values of each of these? And I think we've actually already done the sine and cosine of both of these. So the only thing we have to do is fill in the tangent. Okay, for the first one, we had -1/2 for cosine and √3/2 for sine. So this was √3/2. This was -1/2. For this one, they were both negative √2/2, -√2/2. And this one was √3/2, -1/2. √3/2, -1/2. Okay, so now tangent is sine over cosine, right? Or y over x. This is the slope of the line that we have here. So sine √3/2 divided by -1/2. And the way that we divide fractions, remember, we've got to flip and multiply the second one. So this is √3/2 times -2/1. We can cross reduce, and this will give us -√3 as our answer. You could also just look at the triangle and figure out what is the tangent of 45 degrees. So we can either do this algebraically or by looking at the triangle. What is the tangent of 30 degrees? It's opposite over adjacent, 1 over √3. Now, because we are in the fourth quadrant, this is going to be negative. Whoopsie, too far. And I'm going to rationalize this. -√3/3 is my final answer. Okay, so we are using essentially SOHCAHTOA with two special triangles. As long as you can figure out where on the coordinate plane the given angle is, you can find the reference angle, use special triangles to find out what are the coordinates or what are the ratios for sine, cos, and tan, and you can use the cast method to figure out whether it is positive or negative. That's kind of the gist of that. All right, we call this the bow tie method. The bow tie method because when we are looking at reference angles, we are looking at reference angles that are closest to the x-axis. So it kind of looks like a bit of a bow tie. Okay, for each question provided two angles that make the statement true. So sine theta of √3/2. Look, this is opposite over hypotenuse. So if I draw an angle and I make my theta in this angle here, in this corner, then opposite √3/2, that means 1 is my third side. Going up to my special triangle, 30 is between 2 and √3. 2 and √3, this is 30 degrees. So this means This angle is 60 degrees. And notice this is positive. Where is sine positive? C-A-S-T. So sine is positive in the top half of my grid. So I'm going to use my reference angle and say 60 degrees here, 60 degrees here. This is where sine is positive, and the ratio will give me √3/2. And the way that I'm going to write it in standard form is by measuring both angles from the positive line. So option number 1, theta is 60 degrees. Option number 2, theta is, so I'm going to call this theta 1. Theta 2 is 120 degrees. So those are both options. Sine of 60 and sine of 120 are both going to give me positive √3/2. Let's look at the next example. The tangent is -1. Okay, negative is just telling me that it's going to be somewhere here and somewhere here, because that is where tan is going to be negative, right? Because in my little cast symbol here, A and T is where tan is positive. So I know it's going to be here and here, and I've just got to figure out what angle closest to the x-axis will give me the number 1. So again, looking at my special triangle, I know it's going to be the 45 angle, right? Because I'm saying that opposite and adjacent are both 1/1, or whatever. They're the same value. So this is going to be my √2. So if this reference angle is 45 degrees, in standard form, what do these two angles represent? I have to start on the positive axis and go all the way around to this point. Essentially 180 minus 45 degrees. This means that my first angle is 135 degrees, right? And then I go all the way around to my second angle, all the way around. So this is 270 plus 45. This gives me that my second angle that would make this true is 315 degrees. All right, so again, reference angle just tells us where we are on the chart, and standard notation or standard angle will tell, standard position, pardon me, will tell us what the angle actually is. Now, cosine of 1/2. So this means my adjacent side is 1 and my hypotenuse is 2. So I'm looking at this angle here. Adjacent is 1 and hypotenuse is 2. So this means my reference angle, I should do this in pink to keep it the same. My reference angle here is 30 degrees. Did I do that right? Adjacent, oops, nope, it is 60 degrees. 60 degrees is 1/2. Okay, if my reference angle is 60 degrees, my cosine here is positive. So that means I'm looking for something here and here where it's 60 and 60. Right? So I got to be closest to an x-axis, and I have to be on the right side of the graph because cosine is positive. So again, in standard position, my option 1 is that theta is 60 degrees, and option 2 is that theta is 300 degrees. All right, and this is essentially our bow tie method. We're using our reference angle to create, to figure out what position the angle is in, and then we use standard form in order to figure out what is the actual value of the angle that we're looking at. And I believe that is the end of our lesson. good luck. And you've got the class today to do your homework for this section, which is in your notebook. So just flip over the page and you can get to work. The answer key should be at the end of the worksheet in your notebook. Good luck, guys.